Unit 5, Section 6.2, Percents and Fractions. In the previous section, we already explained what percent means. It's for every 100, and so as a fraction, it means whatever the percentage is over 100. So if you are asked to convert it to a fraction, your first step is to take whatever the percentage is and put it over 100, and then just reduce that fraction as we always do. So for example, if you are given this problem 65% and you're asked to write it as a fraction or mixed number in lowest form, make sure that you do the fraction. Okay, so since we've already said that it's the numerator is the percentage, the denominator is 100, we initially write it as 65 over 100, and like every fraction, we look for reductions. Well, these numbers end in 5 and 0, which means they're both divisible by 5. And when we do the division, we end up with 13 over 20. That is in lowest terms. Again, to emphasize the initial step, the 65 is the original percentage, that's the numerator. The denominator will always be 100. 84%, since we're changing it to a fraction or mixed number in lowest form, step 1 will be to take the percentage, put it over 100. I take a look at 84 over 100. I do see that they're both divisible by 4. If you see 2, then you'll do it twice, but in this case I do see that it's divisible by 4. So we'll go ahead and divide both the numerator and denominator by the same number, in this case 4. We get 21 over 25. It is a proper fraction, and it cannot be reduced any further. 225% starts off as 225 over 100. Now remember, anything over 100% is going to be more than 1. Okay, so don't be surprised when you get a numerator that's bigger than the denominator, because if anything over 100 will have that. Okay, well, inspecting this, we see that of course this number ends in a 25. This number ends in 0, 0, so that means these are both divisible by 25. So I'll go ahead and divide the numerator and denominator by 25, and I get 9 over 4. 9 over 4 is an improper fraction. In this case, if they are asked to convert it to a mixed number if needed, then in this case you have one additional step to go. You do the division, 9 divided by 4. 4 goes into 9 2 whole times with a remainder of 1 left over. So as a mixed number, 2 and 1/4. Okay, here we have a percentage that happens to have a decimal point in it. Okay, so the initial step doesn't change. If we have to write this as a fraction, we would initially go ahead and write the percentage as the numerator. The denominator will be 100. But fractions cannot contain decimal points, so we have to rid this fraction of a decimal point. Well, we can move this decimal point to the right one place if we multiply that numerator by 10, because multiplying by 10 has the effect of moving the decimal point to the right one place. Whatever I do to the numerator, I also have to do exactly the same thing to the denominator, because I have to multiply by a 1. Well, 10 over 10 is a 1. So in this case, when I do the multiplication, I end up with 205 over 1,000. And now there's no decimal point. I look at the fraction, I reduce it. Well, it ends in a 5 and a 0, so I know that these numbers are both divisible by 5, so I have to divide them both by the same number. Again, I'm really dividing this by a 1, right? Because 5 over 5 is really a 1. And when I do the division, 205 divided by 5 is 41. 1,000 divided by 5 is 200. 41 is a prime number. That means there's no other factors of 41. 41 does not go into 200, and so this would be my answer in lowest terms. Okay, here's another situation that you will see in your homework. Instead of a whole number or a decimal, in this case they've presented you with a percentage that includes a fraction. Okay, so let's see what we'll do. So what you want to do first is, if you have this mixed number percentage, you want to go ahead and take your mixed number and turn it into an improper fraction. So to do that, again, we multiply the 2 times the 17, which is 34, plus 1 is 35. So this is 35 over 2. Now it's still a percent because I haven't changed the percent part. I just changed this mixed number to an improper form. And as we understand, when we want to drop a percent sign, that means we're dividing by 100. So instead of making a complex fraction, I can just do that. I can do the division by 100. So this is exactly the same thing as 35 over 2. And when I drop the percent sign, that means I'm dividing by 100. Well, if we think of 100 as a fraction, we have a division problem involving two fractions. So recall the algorithm for dividing fractions. It is, you keep the first fraction exactly as it is, you change the division into multiplication, and then you take the second fraction and you take its reciprocal. So we turn division problems of fractions into multiplication problems with fractions. And then, as always, before we do the multiplication, let's go ahead and look for cancellations of common factors. Well, 35 and 100 are both divisible by 5, so I'll do that. 35 divided by 5 would give me a 7, and 100 divided by 5 would give me 20. There's no other cancellations, and so now I'll go ahead and multiply straight across. 7 times 1 is 7. 2 times 20 is 40. And since I had no other cancellations, that means that this will be in lowest form. So converting, again, a mixed number into a fraction. Step 1, convert the mixed number into an improper fraction, which you then drop the percent sign by dividing by 100. When you divide by 100, you take the reciprocal and multiply as shown, and then you complete the problem. In the previous examples, we took percentages and converted them into equivalent fractions. In this section, we're going to take a fraction and convert it into a percentage. And this is a little bit easier because we've already done proportions and we see how easy working a proportion is. Since we are starting with a fraction and we know a percentage can be written as a fraction, you know, it's the percentage over 100, then this sets up a very easy proportion. So we want to find an equivalent percentage, so that means we have to set the numerator at denominator at 100, and this will be our unknown. And when we solve this proportion for p, that will give us the percentage. So as always with a proportion, we do our cross multiplication. And so 5 times p is 5p, and then 4 times 100. And then we lastly divide both sides by the coefficient of the p term, in this case the 5. And when we do that division, we get p is equal to 80. Okay, so that result means that it's going to be 80%, because the result, the numerator of any fraction over 100 is the equivalent of that numerator with the percent sign. So it's 80%. Okay, solving 5/8 as a percentage. Again, we'll use a proportion because it's easy. So we do the cross multiplication. We get 8x is equal to 500. We then go ahead and do the division. So we divide both sides by 8, and then using your calculator, you would get the answer of 62.5. Since the 62.5 is the numerator over 100, that means your answer will be 62.5%. Five over 12 as a percentage. So anytime we start with a fraction, want to convert it to a percent, let's just set it up as a proportion. Do our cross multiplication. When you divide by 12, both sides by 12, you get 41.666, and I'll put the bar to represent repeating 6. And so in a case like this, you really got to look at the problem, because they're always going to tell you what place to round it to. So in this example, it says round to the nearest tenth. Okay, so that means that this number right here is in the 10th location. So the decision is, does that stay a 6 or become a 7? Well, to the right is the number 6. Since it's 5 or higher, that means we will round up by one place. So the final answer will be 41.7, and since this represents something over 100, we can add the percent sign. 41.7%. You'll see a word problem something like this. In a recent survey, 320 workers were asked if they would hire their own boss if they were in charge. A total of 160 workers said no, they would not. What portion of the workers said no? So when they ask the question about a portion, it's basically the part over the whole. And so in this case, the portion of workers that would say no was the 160 over 320. Now notice that they want you to write this in three ways. First one is a simplified fraction, so let's go ahead and do that. So we have 160 workers out of 320 that said no. Well, we have to reduce the fraction. The fractions, the numerator and denominator end in zeros, which means they're divisible by 10. So dividing those by 10 just moves the decimal point. And 16 over 32, well, 16 divides evenly into 32. So as a fraction, a simplified fraction, that would be equal to 1/2. As a decimal, well, you can convert any fraction to a decimal by doing the division. So 1/2 as a decimal, if you do 1 divided by 2, you'll get 0.5. Then lastly, as a percent, well, we've done some conversions of decimals to percents. If we want to add a percent sign, that means we multiply by 100. So, and by multiplying by 100, I'll just write this even though you don't need to, because that means we're going to move the decimal point 2 places to the right. And when we do that, that would be equal to 50%. So this shows the tying together of fractions to decimals to percentages. That concludes this section.